Welcome to the chapter Apply, Data Consistency and Validation. This chapter explores how can organizations ensure their impact data remains credible when baselines, assumptions, and models evolve over time? In reality, no baseline is perfect from the start. Early-stage companies often operate with limited historical data, evolving technologies, and incomplete scientific evidence. Measurement systems improve gradually. The challenge is not avoiding uncertainty. The challenge is managing it responsibly. Data consistency and validation are about three things: transparency, structured uncertainty management, and disciplined iteration. First, transparency means clearly documenting how impact is calculated. This includes stating assumptions explicitly, identifying data sources, explaining the choice of proxies where direct measurement is not feasible, and outlining known evidence gaps. Transparency does not eliminate uncertainty. It makes it visible and reviewable. Second, it is important to deal with structured uncertainty management, distinguishing assumptions from risk. Assumptions are methodological choices made when data is incomplete. They are part of the model. Risk, within the 5 dimensions of impact, refers to the probability that actual outcomes differ from expected outcomes. Assumptions are about how results are calculated. Risk is about uncertainty in results. Third, consistency helps disciplined iteration. Consistency means documenting changes, maintaining traceability over time, and avoiding arbitrary shifts in methodology that artificially inflate results. In practice, this requires version control of impact models, clear documentation of baseline updates, and structured review cycles. Validation strengthens this process by ensuring internal review, peer benchmarking, or collaboration with scientific or industry partners who assess the robustness of assumptions and models. Data credibility is therefore built through disciplined iteration, not static perfection. Let's look at an example. Consider an early-stage company developing a marine carbon dioxide removal solution. At deployment, the company does not yet have long-term ocean monitoring data to quantify net carbon sequestration. The causal chain between activity and atmospheric carbon reduction is scientifically complex and still under study. To move forward responsibly, the company first defines a baseline scenario describing what would occur without the intervention, and then builds a simplified impact model based on laboratory data and conservative assumptions drawn from peer-reviewed literature. Under transparency, the company clearly documents which parameters are measured directly, which are estimated, and which are assumed. Under uncertainty management, the company acknowledges uncertainty around permanence and ocean circulation variables, and reflects this uncertainty in conservative impact estimates. Over time, as field trials generate empirical data, the company fosters disciplined iteration by updating its baseline and refining its impact model. To strengthen validation, the company partners with a marine research institute to review its modeling assumptions and monitoring protocols. Through this approach, the organization maintains credibility even while scientific knowledge and operational data mature. Data consistency and validation are not about rigid methods or perfect baselines. Impact measurement is iterative. What matters most is clarity, traceability, and integrity. This voyage takes us from promising ideas to proof of real ocean impact.